So we're gonna start with problem one. If a and b are positive integers, then a squared minus b squared equals 143. What is the value of a? Now, but remember from last class, we used the formula. It's known as difference of squares. Is that a squared minus b squared is equal to a plus b times a minus b. Now, in this case, we can write it as a plus b times a minus b, which is equal to 143. And since 143 can be known as 11 times 13, we can let a plus b is equal to 13 because a and b are positive integers. So it's always going to be the sum of the two integers is greater than the difference of the two integers. This gives you a plus b equals 13 and a minus b is equal to 11. So now we can start solving, and solving gives us a equals 12 and b equals 1. This gives you the answer of C. Let's move on to problem 2. The sides of the right triangle are consecutive even integers, and the length of the longer leg is x. Which of the following equations could be used to find x? I'll let you guys have a try on this question and tell me your answers to chat. Okay, let's get started with this question. Now that we got it right. So how are we supposed to solve this question? We can draw the right triangle as always. It's good to draw a picture and have the diagram seen in your eyes. So let's do it. Uh, this is not accurate. As you can see, these are not consecutive integers lengths. So let's just go with it. So let's say the longer leg is x. This means this is x plus 2 because it's consecutive even integers. Like, for example, 1, 2 are consecutive integers, and the consecutive even or odd will be 2 more because the next one's definitely not the same parity or the same, basically, parity. And this is going to be x minus 2 because it's going to be the the one before that has the same parity or the same even or oddness. So this gives you, by Pythagorean theorem, gives you x minus 2 squared plus x squared is equal to x plus 2 squared. Because the Pythagorean theorem states that if we have legs A, B, and C, It states a squared plus b squared is equal to c squared, which gives you answer as C. Okay, what's your question?
So I was wondering, you know how like the whatever it's called theorem? Basically, you're supposed to like square on like a squared plus b squared equals c squared. Can I use like square root the whole thing like two times and you get a square root of c equals a plus b? Does that work?
No, it's because if we were to square root, let's see, we square root the entire thing. This gives you C is equal to square root of a squared plus b squared. Notice that this is not some is not a perfect square. How we would make a perfect square is making it such that, hold on, let me move this. A perfect square is in form of k squared for some integer k. Alright? So if you want to make a perfect square out of a and b, it's going to be a squared plus 2ab plus b squared, or is equal to a plus b squared. And in this case, you just need to know this is not necessarily a square on every single case. So when you take the square root again, it's kind of redundant in at least the next square root. So what you can just do is just square root it once, unless you're trying to solve for the square root of c. But sometimes it's not an integer. So what do you have to say, Jet?
It was an accident. Sorry.
Oh, okay. Anyways, let's move on to problem 3. If a and b are positive odd integers, which of the following must also be a positive even integer? The key words here are obviously even and odd. So this is really important. Make sure you read the question, or it's like you're not gonna be able to see what's if it's even or odd. So like you might mistaken it as just only integers, which is not good when you try to problem solve. Anyways, how would I solve this question? Well, first, a let's consider a plus b. A plus b. We know that it's same as odd plus odd, which is equal to even. This is a key fact. You're gonna experiment and all odd plus odd is equal to even. And since we want a positive even integer, this gives you the answer. A plus b is indeed an even number because an odd plus an odd is even. So the answer is A. And A minus B, well, why doesn't it work? Remember the question. Remember the statement. Positive odd integers, which must be a positive even integer. See, it's trying to trick you. It's thinking that, oh, it's only even integers. But in reality, it has to be positive. And we do not know if it is positive. Like, A minus B, for example, if I let A be a 5, B equals 7, you'd get an even integer, sure. It's going to be 5 minus 7 is equal to -2, but that's not positive. So we can rule this out. Similarly, 2 times A is even, and an even plus odd is always going to be odd. So this one can be ruled out. Same for D, E, we do not know because an odd plus odd is even. Divided by 2, we don't know if it's either odd or even. So we can rule that one out. Let's move on to problem 4. I think it's pretty similar to the one we did last session. So let's try to solve it. If x and y are consecutive even integers, where y is greater than x, which of the following is equal to y squared minus x squared? Try to use the consecutive even integers. What can we do from it? And since it's y is greater than x, maybe it might be helpful that you write y in terms of x. Since it's a consecutive even integer, you might want to write it as x plus 2 of that squared. I'll let you consider letting y is equal to x plus 2. I'll let you guys have a try on this question and tell me your answers to chat. Please, private message. Okay, let's get started with this question. So consider y is equal to x plus 2. Now, plugging in y equals x plus 2 into this equation gives us x plus 2 squared minus x squared. If you guys don't know how to expand a binomial, try using FOIL. Do x plus 2 times x plus 2 minus x squared. Keep on the x squared, but we're not going to focus on this on right now. We're going to expand this. Using FOIL, it states first outside, I think, inside, uh first and the leftover, I think. Correct me if I'm wrong, but the point is we start with first. So the first is this one and this one. So we already done first, outside, this one and this one. Inside, now go on to green. Those connections are literally showing what we should multiply. And leftover, or I think it should have been last. It sounds like much better, so I'm gonna change it to last. And then last gives you this one and this one. This gives you last. Because that's how you do the FOIL method. So we multiply. First gives you x squared plus outside x times 2 gives you 2x. Inside gives you 2x. Uh, Last gives you 4. Adding these all up gives you, this is equal to, you can extend from there, x plus squared plus 4x plus 4 minus x squared. These two cancel out. X squared minus x squared is 0. And this gives you 4x plus 4. So the answer is E. Alright, let's move on to problem 5. X and y are consecutive integer, odd integers where y is greater than x. Which of the following is equal to y squared minus x squared plus 8? I might be honest, this is pretty much the last question, but adding something. I'll let you guys have a try in this question and tell me your answers to chat. What's your question?
Uh, can I look at the last question's answer?
The last question's answer was E.
Okay.
Uh,
I don't see anything. It's just now it just said teacher has yeah yeah.
is this good? Okay, let's get started with this question. Surprisingly, the answer is the exact same as the last question. I don't know why. What's the purpose? It's just probably because it's still basically the same form. It doesn't matter. We can still let y equals x plus 2. We did before y squared minus x squared is equal to x plus 2 squared minus x squared. Should give you 4x plus 4 like in the last question we stayed on. It's probably going to give you, it becomes way easier if we just add an 8. That's all we did. And it just gives you 4x plus 12. The only tricky thing is factoring. It just factors it. We find the greatest common divisor of the coefficient or 4x, 12 because they might share an x and we can clearly see that they don't share any x's. But we do know that 4 divides 12. So we can see it's equal to 4. So we might as well factor a 4. This is x plus 4 times x plus 3. Let me make that x neater. It gives you an answer as E. Okay. Let's move on to problem 6. If A and B are odd integers, which of the following must also be an odd integer? I'll let you guys have a try in this question and tell me your answers through chat. Sorry, I apologize for the inconvenience. It is a answer is a. This one is even. That one's also even. A plus 2 is odd. A plus 2 times B is gives it odd. So it'd be A. Alright? Let's move on to problem 7. It seems like this question seems like a big chunk of letters. But anyways, problem 7. If T represents an odd integer, which of the following expressions represent an even integer? I'll let you guys have a try on this question and tell me your answers through chat. Okay. It seems like now everyone pretty much got the question. Which of the following expresses an even integer? It's E. Why? Why is it E? 5t is odd because 5 times odd is equal to even. Now from odd times odd equals even. Odd times odd equals odd. Odd plus odd is even, so you get this is even. Can check the rest are not right because they give an odd integer. So the answer is E. Let's move on to example 14. I'll let you guys have a try on this and tell me your answers to the chat. Guys, let's keep the chatting on topic. Uh okay, just put in the numbers. Don't put the letters. I don't know why there are letters here, but just don't put in the letters. I'm about to cross it off. I have a better idea. I should do this. You guys can't see it no more. I shouldn't get started with this question. Mr. Mathis and his student Peter worked together to solve math problems last week. I'm probably sure it's homework. Whenever a person solves a problem, he would put a marble in his own box. Kind of a reference to like Squid Games, but anyways, Mr. Mathis's problem solving speed was half of Peter. And so a little comment here. I thought he was the teacher, but anyway, Peter had 4 boxes of marbles, and Mr. Mathis had 2 boxes of marbles. Um, each box is labeled with the number of marbles inside it. The numbers the numbers are 78, 94, 87, 82, 80. Which two boxes belong to Mathis? So how are we solving? The total number of uh uh marbles in every single boxes. I'll write it down. Oops, I'm still on highlighter. Oopsies. 507. And since Peter's speed is twice as much as Mathis's speed, Peter has twice as much. Assume Peter has 4x. Then Mathis, or I meant 2x. To just get the sum. 2y plus y is going to 507. Calculating this gives you Mr. Mathis, or y, has 169. Okay, 169. Anyways, 69 and 26. But anyways, an odd number. So it has to be one odd, one even. By investigation, we can see 87 plus 82 gives you 169. So the numbers are 87 and 82. Alright, so let's move on to example 15. All positive integers greater than 1 are arranged in 5 columns. A, B, C, D as shown below. Continuing the pattern, in what column will the integer 800 be written in? Let's you guys have a try on this question and tell your answers to the chat. Anyway, let's get started with this question. Yeah, it will be in B. We can see 2, 3, 4, 5. We can see every row has two integers, right? Two integers meaning that if it's the 4K plus second, okay, you can see it repeats every we can see this it repeats every 8. So it's either on B or D. And if it's the 8K plus second, oops. I mean if it's a 6K plus second integer, if it's if it's like the second, if it's the what first, fourth, uh, fifth. Let's try to see a pattern here. Every row has two integers, so we're gonna try to split the rows, and then we can get there's two even integers in each row, and from there we can see that 800 the 800 is the 400th even integer, or it's gonna be in the 200th row. The 200th row is gonna be row 5. And the last even integer in the 200th row is the same color as the last even integer in the second row, which then gives you that since 2 is equal to 5, we get that 8 is equal to 18. From this example, 8 is equal to 18 and 6 is equal to 20. We give you 800 is going to also be in B. So the answer to this question is B. Okay, let's move on to example 16. I'll let you guys have a try on this question and tell me your answers to chat. Let's get started with discussion. So, if the lamp is switched an even number of times, it does not change its on or off state. And if the lamp is switched an on number of times, it changes from an on to off state or from an off to on, depending on the original on-off position. Realize A to E, it starts from the term switch from A to E, and he repeats the pattern. So it's gonna be like, it's gonna be on, first turn, on, oops, on, second term, off, 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 off. It then gives you, since 126 is equal to 5 times 25 plus 1. If it's an odd number of times, it's going to be on. One of them is going to be on. I mean, One of them gonna be so all of them are gonna be on the odd number of times, but then they're gonna and then uh what's his name? Ben is gonna turn one off because of the remainder one. Okay, what's your question?
Oh, so like I have like another way of doing it. It's kind of like same thing, but like different, like kind of easier because there's five lights. You flip them five times, they all turn on. You flip them five more times, and they all turn off. So it's 10 times and it'll stay the same. And there's 12 10 times in 126. So you just have to flip all of them six more times, and and then they all turn on, and then you turn A off because of that sixth flip. And then it's B, C, D, and E. It's kind of faster.
Okay, it's a brilliant explanation. Let's move on. Okay, what's your explanation? Or you have a question?
I think that if we so there's like five, right?
Yeah.
Five lamps and there's 126. All of them are at least 25. So I'm correct at least. I think it's if 5 times 25 it's 20, yeah, I feel like yeah, I think the last one will be turned on, like all of them like be turned on. Like in the end. So 125, right? If you 25 times 5, you get 125. So I think it's E will be the last one to be on, I think.
Okay, since it's turned on odd amount of times, we know that all of them are gonna be on.
Yeah. So I think it's either A or E.
No, it's gonna be A that's gonna get turned off.
Uh
Because it's gonna be turned on the first time A, B, C, D, E. This is the odd or what first term. Second term A, B, C, D, E is gonna be turned off. And then so on.
you mean the outweigh?
What?
Oh, I thought you mean like every lamp turns 5 times. Every time. So I thought the question meant like you turn on the lamps, like if you the first five, you just get 126 minus like subtracted by 5. So 121. I'm sorry, like you mean
That
like
way. You can think it that way if you want to.
yeah. I think it's like that way.
Yeah. Let's move on to problem A. It's x plus 7 divided by 2 is an integer, then x must be to guys have tried this question and tell me answers to chat. Get started. So X must be an odd integer. That's the answer. Why isn't that like a? Why can't we say it's positive? Well, the even and oddness can be extended to the negative dimension. You can, if you can say, you can send it to the negative part. For example, -2, we can just say it's even. Just like 2 is in the positive one is even. So, in this case, we know it's an odd integer because opposite odd gives even. Even though 2 is always going to be an integer. All right. So yes, a negative will work too. Let's move on to problem 9. If k is a positive integer, which of the following must represent an odd integer that is twice the value of an odd integer? Let's guys, I'm trying this question and tell me the answers to chat. Okay, let's get started. I don't know why it says twice the value of an odd integer. Shouldn't say that, but it's probably meaning that it's gonna be like a bit more than twice an odd integer. I don't know, like this wording's kind of like, like it doesn't really quite make sense. And some competition problems are gonna be like this. I don't even know why and who made these questions, but the key takeaway is that to make an odd number, we know that if we multiply 2, it seems like most of them are multiplying 2. If we add an odd number to the even number, since we multiply by 2, for example, we have 2k, and then we add an odd, this will give you an odd number. Anyways, since we want twice an odd integer, and we can express any odd integer as 2k plus 1. We can multiply that by 2 and then add 1. And this gives you an odd integer that's like it's about twice. So 2k plus 1 times 2, this gives you uh 2 times 2k plus 2 times 1 plus 1. This gives you 4k plus 3, which points at the answer of A. Let's move on to example 10. I'll let you guys have a try on this question and tell me your answer to chat. Okay, let's get started with discussion. The answer to this question is C. If k is a negative even integer and n is a positive odd integer, which of the following could be equal to n minus k? Since k is a negative even integer, n minus k, let k be equal to negative t, a negative even integer. N plus t, t is even. This gives you odd plus even, which is going to be odd. So it should be 2 and 3. I don't know why they're not 1. It's probably because you can't get 1. And it has to be at least 1. And because why it should be at least 1? Because an odd integer should be at least odd 1 if it's positive. Uh thank you so much meaning thank you so much means TYSM. But anyways, so the answer is 3. Only 3. From 11. I'll let you guys have a try on this question and tell me your answers to chat. All right. So let's get started with this question. Uh, sum of the positive odd integers is less than 1,000. Is subtracted from the sum of the positive even integers less than or equal to 1,000. So that's a total of 500 even integers because the number of even integers equal to 1,000 divided by 2 are 500. There's 500 odd integers. So an odd integer can be expressed as 2k minus 1. Even an integer can be expressed as 2k. And we subtract that, we always get 1. For example, we can just do 2 minus 1, 4 minus 3, and so on. We can make pairs, or 500, we can make 500 possible number pairs. We choose one number from the 500 odd, one number from 500 even. Subtract that, we get 1. And do that every time, we get 500. So the answer is 500. And this, let's go. So our last question is probably going to be problem 12. So in this case, each of the 75 children in a line was assigned to one of the integers from 1 to 99. I'll let you guys have a try on this question and tell me answers to chat. All right, let's get started with this question. Each of the 75 children in a line from 1 to 99, then standing in the same order, the children counted off in the opposite direction, so that the child who signed the number 99 the first time was assigned the number 1 the second time. Which of the following is a pair of numbers assigned to the same child? Right. From the list, we can see that the sum of the two numbers has to be 100. 99 to 1, 98 2, and so on. So we can just look for the ones that are the sum equal to 100. This is not the sum equal to 100, sum not equal to 100, sum not equal to 100, sum not equal to 100, and 33 and 67 actually sums to 100. So the answer is D. It's 8 o'clock. Okay, you can spam now. I hope you have a good day. I'll see you next session, which is next week. Bye.